Hello dear students, welcome to my channel Patel Science Academy, and in this lecture the topic is hormonal control of pregnancy and lactation. So dear students, as you know, this is Patel Science Academy by Shahzad sir, and in this lecture the topic is again related to our chapter reproduction in lower and higher animals. So dear students, as you know, this is lecture number 7, and in this lecture number 7 I'll teach you about the different topics from the chapter. So early embryonic development, what are the changes and what happens during this early embryonic changes in the female body. After fertilization, the embryo spends the first 4 days in the oviduct, that is in the fallopian tube. As you know, fertilization is the process of fusion of male gamete with the female gamete, and after fertilization the embryo, the developing fetus, the developing next generation, it spends first 4 days in the fallopian tube. The tube, as you are familiar with, as a part of the female reproductive system. So dear students, thereafter, what happens after the 4 day? The developing embryo is then transferred to the uterus, in which that fallopian tube opens and it implants in the uterine endometrium. Then by the day number 6, the trophoblast cells of the embryo begins to produce one hormone known as human chorionic gonadotropin hormone. In a normally developing embryo, hormone human chorionic gonadotropin hormones levels, and in a maternal circulation will double every 3 days, reaching peak at about second month of the pregnancy. So as you know, dear students, this is that diagram I explained you earlier too. This is the lining of the uterus, that is called endometrium, and this is the developing embryo, that is now it is having the inner mass, that is called embryoblast, taking its position at one point. You can see at a green, in a green color. Then this is the layer of trophoblast cell, and this space appears. This space is called blastocyst cavity or blastocele, and this structure is called, dear student, this structure is called the blastula. So there are these different changes that takes place early embryonic, as early embryonic development in the female body. Then what happens, the levels of the hormone like the progesterone, and what happens with this progesterone, and what are the changes takes place in the female ovary, we'll see. To maintain the uterine endometrium and inhibit the contraction of the myometrium, plasma progesterone, the hormone secreted in the body of the female reproductive system, it levels and must be maintained during the pregnancy. So this is again most important hormone, that its level must be maintained during the pregnancy. Early in the pregnancy, this is accomplished by the action of the HCG, that is human chorionic gonadotropin hormone, on the corpus luteum at about the first 8 weeks of pregnancy. Later in the pregnancy, the progesterone hormone level is produced by the placenta. So as you know, dear students, this is female reproductive system, and in this female reproductive system, you are already familiar with, this is these are the ovaries. One pair of ovary is there always in the female reproductive system, which is attached by this uterine wall, by this ligament you can see here, and it opens into this long tube, and this tube is called, as you know, it is fallopian tube, and it opens into this space called uterus, and these are the lining of the wall of uterus, endometrium, myometrium, and this opens into this narrow passage, that is called this cervix, and which opens into this vagina, which is the opening of the female reproductive system outside the body. So dear students, this is about this slide, and This is about the progesterone hormone role in the female reproductive system during the pregnancy. Action of the hormone HCG, that is human chorionic gonadotropin hormone. What are the actions? Let's see. HCG binds to the LH luteinizing receptors in the corpus luteum and maintaining the luteal steroidogenesis during the first 8 weeks of the pregnancy. And in addition, HCG may act to stimulate the testosterone hormone production from the developing testes in the male embryos. These are the functions of this HCG. So dear students, in the uterus, in this ovary, you can see here the changes. This is the ovary and this is its corpus luteum. So what are the role during the blastocyst? HCG and HCG, it secretes progesterone and it maintains the pregnancy in the endometrium wall by having the changes in the endometrium wall. Then the estradiol progesterone level inhibits and anterior pituitary glands, and the hypothalamus role is also there. We'll see in the detail in the next lecture too. So dear students, this is about the action of the HCG, that is human chorionic gonadotropin hormone. Thereafter, the steroid production by the placenta. Later in the pregnancy, the placenta becomes the major steroidogenic organ of the pregnancy, and this placenta is most important part. However, the placenta requires the maternal LDL as a source of the cholesterol for the progesterone production. The placenta is dependent upon the maternal and the fetal adrenal as a source of androgen hormone for the aromatization to produce the estrogen hormone. And estrogen, this hormone, may be important in increasing the uterine blood flow to fetus and in the maturation of the fetal organ systems. This is about the estrogen. Then the process of parturition, the process of childbirth from the body of mother. The mechanism signaling the onset of labor are not clearly understood, although several theories exist, like the potential role of the progesterone. It includes the decreasing progesterone prior to the labor would cause uterine contraction to occur, and however there is no decline in a progesterone before labor in the human, while some studies suggest that there is a decline in or decrease in a uterine progesterone receptor, resulting in the decreased progesterone action leading to the labor. So this is that process in which the childbirth, that is the process of the birth of child from the female body, that is called parturition, it takes place. Then dear students, the positive feedback cycles that contributes to initiate of the parturition. As you know, parturition is the process of childbirth. So CRH, that is the corticotropin releasing hormone. I'll explain here diagrammatically. In this explanation, the green arrows indicates the stimulation, while the red arrows indicates the inhibition. So just remember it, green arrow means the stimulation and red arrow means the indication of the inhibition. So as you can see here in this graphic representation, this is the progesterone hormone, and this red color arrow, it indicates that CRH, corticotropin releasing hormone, it is inhibited, and then thereafter changes the cholesterol level, cortisol level, and the prostaglandin there is a increase stimulation to this cortisol and this prostaglandin, and as by the situation there is a decrease or inhibition in the prostaglandin level. Then the progesterone, if it inhibits the uterine contraction and the cervical wrapping, the estrogen level it increases or stimulate, and then it goes for these changes includes the cervical ripening and the decline in the uterine contraction by the progesterone hormone. So this is about the role of the progesterone hormone, and this is the positive feedback. Now, potential role of the hormone oxytocin in the parturition. What is the oxytocin? This hormone role by the pituitary gland, and why it is called birth hormone, we'll see it. Oxytocin causes the uterine contraction, and however the oxytocin level do not increase until after labor starts, according to more recent studies. Oxytocin may play a role in the uterine contraction following the labor, resulting in the decreased blood loss. You can see here diagrammatically in this one diagram, in this second number, third number, fourth number, and lastly likewise this process of parturition takes place, means the fetus from the mother uterus is triggered from the body, and lastly it comes out from the body, and this process is called delivery process, that takes place by the process of the parturition, and which is the indication of this labor before it. So dear students, the potential role of the relaxin hormone in the parturition, now we'll see. Another marker of the corpus luteum function is the polypeptide hormone relaxin, and relaxin become detectable at about the same time as HCG begins to rise, and the certain contractions are maintained for the remainder of the pregnancy until labor. The relaxin also decreases uterine contractility during the pregnancy, and the relaxin act on the cervix, causing the dilatation and softening. Relaxin does act to soften the connective tissue, such as the ligament connecting the pelvic bones, to allow increase in the size of the birth canal. So you can see here diagrammatically the role of the relaxin in the process of the parturition, that is the process of the childbirth. Thereafter, the potential role of one more hormone, that is called prostaglandins, during the process of the parturition. The prostaglandins causes dilation and softening of the cervix. It also causes the uterine contraction. The levels of the prostaglandin increase in the fetal membranes before the onset of labor. Then the process of after the process of parturition, after the fetus has comes out from the body, then the process of the lactation start. And what is this lactation? We'll see. Lactation is the delivery of the milk from the mammary gland of the female body. There are four main stages of lactation controlled by the different hormones. Number one, it includes the milk synthesis in the alveolar cell of the mammary gland. Then number two, lactogenesis, the secretion of the milk from the alveolar cell to alveolar lumen. Then the next is galactopoiesis, the maintenance of the milk production and the release into the alveolar lumen. Then the milk ejection, after the production of the milk, after the lactogenesis, after galactogenesis, the process of ejection of the milk will be takes place, and it is the movement of the milk from the alveoli into the duct system and out of the breast. This is about uh, this is about lactation. As you can see in this diagram, uh, as you can see in this diagram, this is the structure of the mammary gland, and these are the alveolar gland. You can see here in the pink color, and this alveolar gland, it it has the areola, and this areola, it is having this nipple, and in this there are fat tissue, there are alveoli. You can see here, this is alveoli, these are fat tissue, and in this alveoli there is a duct which is connected. This alveoli is connected to this duct, lactiferous duct, and there are also lobules. These lobules consist of different alveoli. You can see here, these are the lobules, and in this lobules there are different alveoli. This alveoli is connected to the lactiferous duct by which the milk will come out from the body, from this mammary gland, from this breast. And so dear students, in this structure you are observing here, this orange color structure is the lobule, and this network like structure is alveoli present in the lobule, and this yellow color dot indicating the fat tissue, and this fat tissue, this lobules in which alveoli is there, and it is connected with this duct. You can see here in this blue color, and from this duct the milk flow takes place outside the body by this lactiferous sinuses. Then thereafter the then thereafter one more time diagrammatically we'll see here the process of lactation. As you know, dear students, this is alveoli, and these alveoli is connected with this duct, that is a tube, and this areoli is also there, the border of this breast. And if you zoom it, it will look like it. Alveolus is like this oval shaped structure which opens into this ductule, this into this tube, and it is this alveoli is having lactocyte cell which is responsible for the formation of the milk and for the ejection of the milk finally. So lactation is nothing but the process of delivery of milk from the mammary gland after the parturition, after the birth of the fetus from the female body. Then some more detail of the lactation. Milk synthesis. Milk synthesis includes the production of the breast milk is stimulated by the increased level of the hormone prolactin, which is secreted by the pituitary gland, and the HPL, that is the human placental lactogen from the placenta. So you can see here, from the pituitary gland and from the placenta, different hormones are releasing during the pregnancy stage, and thereafter the milk release from the alveolar cells of the mammary gland, that is breast, and it is inhibited by the high levels of the progesterone and the estrogen during the pregnancy, and thereafter the process of estrogen and progesterone also act with the prolactin hormone to increase the alveolar duct and growth, duct growth during the pregnancy. So this is about this lactation, milk synthesis. Then it also includes the lactogenesis process. What is this lactogenesis process? The stimulated by the prolactin hormone, and it occurs after the parturition. Definitely it will be occur after the parturition, and when estradiol and the progesterone levels decrease. So after the decrease of the level of estradiol and the progesterone hormone, the process of lactogenesis will occur. This is about this lactogenesis. Then what about the galactopoiesis? What about this process? Dear students, galactolysis is the process of maintenance of established milk production caused by the hormone prolactin secreted by the pituitary gland. Then the process of milk ejection process, it includes the movement of the milk from the alveolar duct, as I explained you previously, into the main duct system and out of the breast, is induced by the hormone oxytocin. So what is the role of the oxytocin? It causes the contraction of the myoepithelial cells in the breast and causing the milk ejection, that is the release of the milk outside the breast for the nourishment of the fetus which has now taken birth outside the body. So this is about the lactation. Dear students, the regulation of the oxytocin and the prolactin during the lactation. There is a positive feedback effect of the breastfeeding on the production of the oxytocin and the prolactin hormone. Oxytocins, what is the role of the oxytocins? Oxytocin's level increase due to the suckling of the breast by the infant. As you know, infants start sucking to the breast nipple, so the level of the oxytocins by sucking process increases. And in addition, sight, sounds and thought of the infant can also increase oxytocin's level, causing the milk ejection. And prolactin hormone, what is the role? Prolactin release is also increased by the suckling of the breast by the infant, but not by the audiovisual stimuli. So this is about this lecture. Dear students, please subscribe my channel Patel Science Academy. This is your teacher Shahzad sir, and please do subscribe my channel and like my all videos, share with your friends and with all the needies, comments for your queries. Thanks for watching my videos. This is till then Shahzad saying you goodbye. Keep healthy, stay at home. Thank you very much.